What's question 9?
The trapezium.
Shall do Aimo 2000. Question 9 and 10. And then 2001. Is it question 6? 6,
Yeah, this one.
What's that one?
It's question 4.
Oh yeah. Was that interesting? If it's not interesting, you don't have to talk about it. We're going to check your answer as well.
Yes, okay. This is out.
Take it away.
This is trapezium, so here's assuming trapezium.
Yep.
And then it's divided into 4 triangles with its diagonals.
Mm-hmm.
And x and y. So this is x and this is y. And find in terms of x and y the area of the whole trapezium.
Yeah, so it's the top 2 sides.
Yeah.
The horizontal lines that are parallel, yeah. So AB is parallel to DC. So you want to find the area in terms of the areas of the 2 triangles that you labeled, yeah?
So this is how I did it. So first, I'm going to make a box. So the area of this is 2x, right?
The area of what is 2x?
Oh, this.
The rectangle?
Yeah.
Yeah, because it has the same base and height as x.
Yeah.
Yep.
So and that is equal to a b multiplied by. So let's call this height. No, let's call it
h1 or something?
Let's call it h1 and that h2.
Okay.
So this is ab times h1, right?
Yeah.
And 2y is equal to dc times h2, right?
Yeah.
Where h1 plus h2 is equal to the height. So then 2x over ab is equal to h1 and 2y over dc is equal to h2. We should divide it. So then if you add these two together, 2x over ab plus 2y over dc is equal to the height.
Mm-hmm.
And then so we can find the area of the trapezium. So it's a b.
So this is not it. This is just times, right?
Yeah.
And that's your x.
Yeah.
Yeah. Okay.
So
make it clear.
Okay. The area of the trapezium is AB plus DC multiplied by the height times half, right?
Mm-hmm.
So AB plus DC multiplied by
h1 2x.
Two, right?
Yep.
That is equal to the area. And then we can just simplify this. So then we can write the area as 2x plus
You can cancel the 2's, I guess, if you wanted to.
I want to say 2x.
Like, I mean, you could cancel it at the start if you wanted to save some time.
Plus 2y a b over dc, right? 1 over 2. So then that is equal to x plus y plus x dc over a b plus y a b over dc, right?
Yep.
But then you know how that's AB and that's DC.
Mm-hmm.
And so the ratio of the 2 sides would be x to y, right?
Yes.
So then this is in ratio form. It can be written as x plus y plus x root y over root x plus y root x over root y. Cancel. So then x plus y plus root xy plus xy. equal to x plus y plus 2xy.
Oh, that's a really good answer. That's fantastic.
Yeah, very nice.
Pretty good. Okay, good. So that was very well done and written very well as well. Okay.
Next question.
hmm?
Next question. Yeah, this answer.
Yeah, that's right. I mean, there's lots of different ways you could do it. But this is one of the nicer ones. Yeah. Do you know the formula with trig? So obviously, none of the answers in the book will have trig in it. So those are the ones I like to tell people. But do you know? And I'm sure this particular way of doing it wasn't exactly in the answers either. So that's good. Do you know the formula for the area of a triangle with trig? Yeah.
It's like, I think it's like sine that times that times that.
Yeah. So that's another way of doing it. I can show you.
Oh, yeah.
I think your way is very good. I think your way is better as well. This one is more routine though. It's less imaginative. You know what I mean? So you have like we call this alpha and this beta, right? And this is your x, and this is your y. And then maybe you can call this z. I guess it's interesting that z and w have the same areas, yeah? Because they're both equal to root xy. So obviously this is beta and this is alpha. Yeah. So then you can write x equals. Okay, so we label these signs as well. So maybe we can write this as a, b, c, d. Yeah. The x is half a b sine alpha. Yeah. Y is also half c d sine alpha. Z is half a d sine beta, but actually sine beta is the same as sine alpha. Yeah. Sine beta is equal to sine alpha because they're 180. They're supplementary. Yeah. And then w equals half bc sine alpha as well. Okay. So yeah. So for example here, z equals to x. So it's no longer b, it's d, right? D times it by d over b. Yeah. The d over b is this ratio, d over b, right? And then so w, you can also write it as x. So you can write it as y. It doesn't make it. It doesn't actually change, but maybe. Let's do it for y then, for example. But maybe it depends on what you feel like doing. So you got to get rid of the b and put in the d, right? Sorry, if you want to go y, you got to get rid of the d and put in the b. Yeah. Yeah. So then like, and obviously the final area you want to find is x plus y plus z plus w. So here you have that b over d. So do you know that these triangles are similar, right? That's how you got the ratios with the same. Yeah. So then not only so one way to express the similarity is that x over y, yeah, is equal to b over d squared.
I try to prove that z and w are congruent.
Oh no. I don't think they are congruent. They're the same area, but these could be. Yeah, they don't have to be congruent, I don't think. Okay, so basically I'm saying that x on y is this square, right?
Yeah.
So then you can just square this. Yeah.
Yeah.
So this becomes this squared. Yeah.
Yeah.
This becomes this squared. Yeah. And then b on d squared is just x over y. Yeah. W squared equals y squared times x over y. And then this is x squared times y of x. Yeah? That makes sense?
Yeah.
So then this is, they're both equal to xy. Yeah?
Yeah.
So then they're root xy. So then it's x plus y plus 2 root xy. Yeah. So I would say this is a worse solution than the one you get, but it's one that you could think of very quickly, and the steps are pretty routine. Yeah. Okay, good. So that was question 9. Yeah.
Yeah.
All right, let's go move on. Which one do we do next? 10.
No, I'm good.
You don't want to do 10?
Yeah. I still haven't completely solved it yet.
You just did, didn't you?
Can't-
Do you want me to present your solution?
Okay.
Okay. Yeah. So, question 10 asks for maybe I'll present some of my thoughts and then I'll present your solution. Yeah.
Okay.
So question 10 asks for, so g of n is the number of pairs x, y are positive integers. So x, y are both positive integers. So these are ordered pairs. So x, y, and y, x are different if they're not the same number. Such that 1 on n equals 1 on x plus 1 on y. Yeah. Yeah, and the question takes you through g of 10 and stuff, but it's really unnecessary. Maybe we could just ask you what g of 2000 was. Yeah. And I think, as problem solvers, you'll naturally try to figure out what g of 2 and stuff are.
Oh, yeah.
Yeah, so that's the question. Okay, and then so for g of 1, obviously, 1 can only be half plus a half, right? And yeah, anything else they'll be too small to add up to 1 or too big. Yeah. So if these are less than 2, bigger than 2, then they'll never add up to 1. Yeah. Okay, and it gets kind of interesting when you look at g of 2, right? Because we see that half equals a quarter plus a quarter, right? And it also equals to a third plus a sixth, 6 plus a third, right? And the way I thought of why there weren't any more is because if 2 of these have to add up to a half, then one of them has to be bigger than a quarter, and the other one has to be less than a quarter, or they're both equal to a quarter, right? And the thing is, if they're more than a quarter, there's not many possibilities. You have to be a third, a half, or 1, right?
Yeah.
And 1 clearly doesn't work, a half doesn't work, so a third works, but then for every one that works, so for every one of those, there's only one possible thing that could work, right? Because it's like you could just solve for this once you know that one.
Yeah.
So then we know this is 3. But then you came up with a really good way to do this. So you came up with a really good way. Even better than this, I think, because it solves the whole problem. All right, so what did you have? You have 1 on n equals 1 on x plus 1. You just made everything an integer, which is a reasonable thing to do in these kind of problems.
After substituting, because you have to remember. Okay.
Yeah. But it does work for all numbers, I think, what you did. So times everything by x, y, and n, right?
Yeah.
You get x, y equals n x plus y. All right. Yeah, that's what you did, isn't it? You
Oh,
times
yeah,
everything by
yeah,
n.
yeah.
You just clear the denominators, yeah?
Okay.
So then x, y minus nx minus ny equals 0. And then you had this great idea of factorizing. Yeah? So then to figure out what g of n is, it's just to figure out the number of factors. Yeah? Yeah, so yeah, in this case it's 2000, right? And so 2000 squared we know is 2 to the 8 times, well, let's just do it. So it's 2000 squared, right? Which is 2 times 10 cubed squared. This is 2 squared times 10 to the 6, and 10 is 2 times 5. So that's how you get 2 to the 8 times 5 to the 6, right? And basically, I mean, we only care about the number of these x and y, right? So we don't actually have to work out what these are, but you know, we know that these have to be bigger than 2000, right? Because one of them is equal to 2000, the other one's going to make it bigger than 1 over 2000. So maybe you could just think of x and y like this. Replace this by the x and this by y, right? And then you're looking for x and y that times to this. Okay. And it's nice, I guess, because y and x will be different than x and y. So if you look at all the different ways, you won't have to do any doubling or anything like this. Okay. And so, you know, that means x has to equal 2 to the a times 5 to the b, right? And y has to equal 2 to the 8 minus a times 5 to the 6 minus b. And so, I mean, y and x will swap around when a, like when a is 2 and b is 5, you know, this will be the same. This will be 6 and 1, right? And 6 and 1 will appear here too, but it doesn't matter because you care about the order. So can you see that there's basically 9 choices for A, right? 0 to 8.
Yeah.
And 7 choices for B.
Yeah.
So in overall, that's 63 choices.
Yeah.
Yeah. And see, if you had any number, you could just, it's sort of just a partitioning of how to partition the prime factors, right?
Mm.
So any number here, n, right? You look at the prime powers. Whatever those powers are, you double them, right? Because it's n squared here. And then, well, whatever those numbers are plus 1, and you times them all together. Seems like that's. Does that make sense?
Yeah.
Yeah. So that's good. Okay, so that was question 10. Yeah, actually, I want to check what the answer to the back it says because I'm pretty. Well, I like it was better. If it could be better. Oh, it's the same. Yeah, so the answer at the back is the same as your answer. Okay. All right. And question 6, yeah?
Yeah. And question
4, yeah. So, where was question 4 from? 2001?
I'm not sure.
2000. Yeah, question 4 is here. So we've done 9 and 10. Let's do 6. Actually, 4 might be best to do first for some people because it's easy to warm up with question 4. But question 6. So what was question 6? It says
0.33.
Find smallest n integer, right?
Yep.
Such that there exists m. I guess it's also an integer, and that m over n. Actually, this question is kind of interesting. Is it 0.33? Yeah.
Yeah.
So maybe I want to take you through. See, no, like I kind of like to show you a lot of stuff that isn't relevant to the answer as well, because sometimes those go through my head too. Well, most of the time. Okay, so let's look at the kind of things people think about, and then I'll show you kind of the answer we ended up coming up with, the answer that they have, and all this kind of stuff. Yeah. Alright, so the first thought that I had for this problem was try stuff. Okay. See, at this level, like, see, if your algebra was good enough, you might be able to just manipulate and try and solve some stuff, right? But I don't know, for this level, I don't think we've done really inequalities and stuff very much. But anyway, so the first stuff is try stuff, okay? So try stuff. This is the first thing I thought. Because there's nothing more definitive than try stuff. So, for example, 0.33 is less than 0.333, right?
Yeah.
Which is less than 0.3 repeated.
Yeah.
And this is just 333 over 1,000, right? So immediately n is less than or equal to 1,000. Yeah. But that doesn't really tell you anything because the questions in Aimo all have to be less than 1,000.
Yeah.
Okay. But but this idea already gives you some progress. If you put 2 here, right? Then you get 332 over 1,000.
Yeah.
That gives you what, like, but the point is it cancels at least once, right? So that you know that n is going to be less than or equal to 500 now. Yeah? But maybe it cancels more than it's actually divisible by 4, right? To test divisible by 4, you just need to look at the last digit, 2 digits. So then n is already less than 250. Yeah? That makes sense? Because this is equal to, what is this divided by 4? 80, 84, 3. 3? 83, yeah? So it's, that's the first thing I thought, yeah? Might not be the answer. I mean, there's no reason why you can't come up with any other things, right? Second thought was that 100 was too small. It's an observation, I guess. Yeah. I guess the reason I thought 100 was too small was because if it was 100, you wouldn't really like. Because the thing is, the difference lies in this thousandths place, right? So if you had it over 100, I guess I didn't really think about it too much. It just felt like it was too small. So for one reason, because like you can't really get to the thousandths place here with 100, yeah, and if it was even smaller, it'd be even less fine, right? So it'd be hard to hit it exactly on the dot. Okay, so I didn't think about this too much. It just felt obvious. But so that led me to think n was bigger than 100 and less than 250. Yeah. Okay. I guess how much time you take on the question also may depend on how hard you perceive it to be at first. Like if this looks easy, then you probably wouldn't even like do something else, right? I guess I invested a little bit more time because I actually knew like the stats. It said, I don't know if you looked at the stats. It said like only 50 people solved it or something. So I guess I gave it a little bit more respect. So I had information that you normally wouldn't have trying to solve. All right, so that's 1, 2. Okay, the third thing I did was like I said, well, let's try to find some more stuff, come up with some new ideas. So one of the ideas I had was This is 330 over 1,000, right? And this is 330 over 990, right? So I guess my idea was if I could divide it by 5, I would automatically get it less than 250, right? And so these are all divisible by 5. And so I was thinking, well, how do you make it this middle number? Maybe I could keep this 330, right? And I would just need any number between 1,000 and 990 and it would work, you know? So I picked 995 because it's divisible by 5, okay? And so can you see that this is true, right? The numerators are the same.
Yeah.
So if you divide it by 5, you get 199. Yeah.
Yeah.
So the 199 definitely works. You know?
Yeah.
So that's progress. I almost thought it was the smallest at that point. And you know, and so I guess there's kind of two things going on, right? So number 1 and number 3, they're arguments for like what works, right?
Yeah.
Whereas number 2 and number 4, soon to be, is arguments for why it won't work. So then you say it's the minimum, right? So I mean that idea might make so you wouldn't be able to find another multiple of 5 in between. So that was probably the best way to reduce it, unless you found like a multiple of like 8 or something. Maybe that's so. What if you had? So I didn't explore this idea anymore, but now that I'm thinking about it, if you had 330, that's not divisible by 8 anyway, right? So yeah, you can't. So you can't make it divisible by 2 and 5 at the same time, because the number can't end in it can't end in a 0, and if it ends in 5, it's odd, right? So you either pick 5 or 4, basically. Or it's not even divisible by 4, so 5 was the best hope you had. Anyway, so another idea was, let's see, what was the next idea? Oh yeah, so I was kind of going on with the why 100 doesn't work idea, right?
Oh yeah.
And it's got to do with the gap, right? You can't really fit too many numbers in the gap. So what is the gap? Yeah. So this is idea number 4.
Like 0.00333.
Why things smaller won't work. So this I was already thinking 250 was the answer. Okay, so do you know what this is?
0.00333.
Yeah, 0.003 repeater, right? Or in other words, 1 over 300.
Yeah.
You know? So the gap is 1 over 300. So can you see that, like, if n is like, basically if n is like less than 300, you know? That means there's only going to be, if it either works, there's only going to be one thing that could work, and if you move it, it's going to be out of the range because the gap is too small to have 2 different things that works. You know what I mean? There can be at most one thing that works for every value of n. Yeah. Yeah, something like that. And what else? And stuff that's divisible. So therefore, like for example, another observation is that things that n divisible by 3 cannot work. Right? Because if it's divisible by 3, that means, so like say you take like 120, right? You know, the point is if it's divisible by 3, then 120, a third of 120 is 40, right?
Yeah.
Right?
Yeah.
So that can't work because it's equal to a third. Yeah. And so what happens is you have to minus 1, right? But minus 1 will give you, it's bigger than the gap.
Yeah.
Right? So it'll miss the gap. Yeah. So all the multiples of 3 can't work.
Yeah.
Does that make sense? Yeah, so try stuff. So like for example, 150 doesn't work. Actually, I think I saw 150 doesn't work and then I extrapolated and multiples of 3 doesn't work. Yeah. And then try 151. You try 151. 151. So if you do 151, can you see that you have to try 50?
Yeah.
Yeah? Because 51 will be more than a third.
Yeah.
And this is the only one that's less than a third without going even further, right?
Yeah.
So it has to be this or it doesn't work, right?
Yeah.
And actually this works. Because I guess the question is, what's 1 over 151? Well, like, okay, it's less than a third, that's obvious, yeah?
Yeah.
And then, so what's 0.33 times 151? Yeah. So it's 15.1 times 3 plus 1.51 times 3, right? So that's 45.3 plus 4.53. It's 49.83, yeah? So that works. So n is less than or equal to 151. Okay. And then I finally, after thinking about it, I understood why this worked. And so basically, in this range of numbers,
Yeah.
anything that's remainder 1, remainder 3, remainder 1 when you divide by 3 will work. And the reason is because the point is, what does it mean? So let me explain it in terms of 150. So I guess this is step 5. This is step 5. So like, because 150 is a multiple of 3, right? 151 is so 50 over 150 is a third, yeah?
Yeah.
So if you do like 151, okay, this will be less, let's see. So this will be
Less than 300. Or 300. 1 over 300.
yeah, exactly. So when you subtract the difference, right?
Yeah.
So what is this? This is not quite. So this is 3
Oh, I think I got
remainder. It's a 3 plus a third, right?
Yeah.
So
Because you're trying to make that difference like
yeah,
1 over 300, right? But then like since if you do 50 over 150, and like something like you're trying to like minimize the number below. So,
yeah,
like 49 over 150.
yeah. So like, what is a third of this, right? It's 50 plus a third, isn't it? You know what I mean? Yeah, yeah. So this will be a 2 here if it was remainder 2, right? Okay, so if it's plus a third, that means the closest one has to be 50, right? And that'll work if a third over 151 is less than 1 in 300.
Yeah.
Does that make sense? Because then it'll fit into the gap.
Yeah.
And the point is 151, as long as this number is bigger than 100, right? 3 times that is going to be make it less than 300, right?
Yeah. We use times both sides. So 151 is bigger than 100.
Yeah, so anytime this number is bigger than 100, 3 times that will be bigger than 300, right?
Yeah.
So that basically tells you that 100, so 100, right? If you just go up to the next multiple of 3, 102, right? And then you find remainder 1, right? So it's 103. 103 will work. Yeah?
Wait, only
Hmm?
one.
Multiples of 3 don't work, right?
Yeah.
We said that.
Yes, okay. Just
So you add 1 so that this principle applies, right?
Yeah.
And so then 103 works.
Yeah.
Okay. And so basically that shows that n has to be less than or equal to 103, right?
Yeah.
And if you didn't really have time for this, you might be confident that was your answer. And if it's not a proof required, you can just write 103, right? But we had this idea it was greater than 100, right? Actually, how can we show it more rigorously? If we did want to prove it, which we should be doing for homework, right? Yeah, somewhere along the lines, we argue that n is bigger than 100. Yeah, does that make sense? And it's kind of clear that this condition is pretty much set, right? If it's a 2, it's even going to be too big, right? And if it's less than 100, then it's going to overshoot the gap, right? So it has to have one remainder when you divide by 3. It has to be bigger than 100. So this is the smallest one. Yeah. Okay, so let's take a dinner break. Dinner break.